Hi, it's Naomi again. We're continuing our order of operations talk. This is part 2. We went back through part of your schooling and we talked about how addition and subtraction are the same thing, and we know they should be in one step during order of operations, and also how multiplication and division are really the same thing, so they should also be in one step when doing order of operations. Another thing to keep in mind is kind of the ranking of operations. So for example, you learned multiplication after addition. It was addition over and over again, compounded addition. So when you first, were introduced to the concept of 3 times 5, that meant 3 fives, or 5 plus 5 plus 5. Similarly, 7 twelves meant 7 twelves all added together. Now, as you developed your understanding of multiplication and explored with the number sum, you probably figured out, oh, well, 7 twelves, that's 7 tens, and also 7 twos. So I can figure it out. 7 tens is 70, and 7 twos is 14, so 70 and 14. So there are different ways to work with this, but in its most basic form, it's just addition over and over again. Now, clearly, with something like this one, 7 times 12, you see why you want to use multiplication and not addition. It just becomes time consuming to add these numbers up one after the other when you have larger numbers, and 7 and 12 really aren't that large numbers. But for this reason, this idea that multiplication is compounded addition, we get the idea that when we're doing order of operations, multiplication should come before addition because it's a more complex skill and it's building on several additions. So if it's telling us to add several times, we should do that before we do just a simple addition. In the same way, exponentiation is compounded multiplication. So exponentiation, we know something like 7 to the third power. That means 7 times 7 times 7. Note that it's not 7 times 3. Occasionally I'll have students who want to make 7 to the third power 7 times 3. Well, if it was 7 times 3, we'd just write 7 times 3. This is something different. It means that I'm multiplying 7 3 times together. And I get a much, much, much larger number there. 7 to the third power, let's see, that's 49 times 7. So that would be 343. So that's much bigger than 21. And when we're using exponentiation, we find that our numbers grow really quickly. You can start with small numbers and end up with very large numbers. But because, here's another example, 6 squared, we say the 6 squared. The little 2 we say squared, and this little 3 we say cubed. But you can also think of it as 6 to the second power or 7 to the third power. But that just means multiply 2 6's together, so that's 36. What it's not is 12, because we're not multiplying these numbers together. This just tells me how many 6's to multiply together. So exponentiation is kind of a step up from multiplication in the same way that multiplication was a step up from addition, because it's telling us we'll multiply several times, just like multiplication told us to add several times. So for this reason, exponentiation is kind of at a higher rank than multiplication. We get this idea, oh, well, in order of operations, exponentiation, multiplying several times, should come before just simple multiplication. So right now we know multiplication and division go together. We know we have exponents, that's something different, and addition and subtraction. And of course we have parentheses, but we want to put these in order and always have the same order. So parentheses come first because they just tell us what to do first. So since they're telling us what to do first, they should come first. After that, we said exponents were compounded multiplication, and multiplication was compounded addition. So exponents should come before multiplication, and multiplication should come before addition. So that kind of fills in the rest of this operations for us. First we start with parentheses, then we do all the exponents in the problem, then we do all the multiplication and division in the problem, and then we do all the addition and subtraction in the problem. And that wraps up the concepts and theories behind order of operations. Now in the next video, I'll go ahead and do some examples of order of operations problems so you can see order of operations in action and how it helps us to always work problems the same way. Okay, I hope this helps. Bye.